I'm Michael Amato, Planetary and Lunar Line of Business Manager and Lead Engineer at Goddard Space Flight. So I'm going to talk to you about LESSH Lunar Experiment Support System and Handling. Um, I noticed here, I usually try to mess up some bullets when I present on Friday afternoons, see who's paying attention. It's very effective, actually. I just uploaded the old version. But what is LESSH? It's really trying to solve a problem we had at Goddard and other people have. It is essentially a system to solve the challenge of running instruments or ISRU sensors on the surface. Instruments will need power, comm, thermal. The surface is kind of challenging, and all of these measurements we need to do require power, require getting the data back, require astronaut safety. This is an astronaut deployed, designed to be astronaut deployed system. We are funded by ESSIO, a little bit of money to mature the design essentially and build a flyable ETU of the system. We'll try to fill this gap between the instruments and supporting the instruments and the astronaut safety issues, which are rather complex. And we're just combining our tool experience group with our instrument group to design this interface here. A lot of people working on it, a few of which are in the room here, but it's supposed to be a common and customizable, and I'll show you that in a second. This is the need, essentially. One of the things we're trying to do, if you are going after an A3DI or A4DI, I'll talk to you about this afterwards, but it is rather expensive to build the support system around it. We're trying to build something that everybody could use, essentially, not only so that the astronaut interface people, but also the lander people can design to one package. And in fact, we've been using an example there starting ahead of time, but also so instruments can design to something known and you can save money and build more instruments, particularly for institutions who do not build spaceflight hardware all the time. We think this is enabling to institutions to focus on instruments. This is a really big challenge. It's a challenge for us. That's why we started it. So we know it's a challenge for small institutions, and we're trying to build something everybody can use. But you require a lot of things: the interface, the thermal, the power. You have to work with the lander people. You have to work with the astronaut sortie planning people. Instruments, sensors. It's compatible LTV. We have a robotic arm interface, and we're working with a bunch of communities to mature this. I don't have to tell you all about what would drive instruments to go in this, not just ISRU sensors, but also the science. I'm going to skip over this, but ESSIO, like I said, is funding this. November 2021, we have a small amount of money. We're combining our groups, essentially our astronaut tool group at Goddard, which did a lot of ISS support, designing the interface, the astronauts, and the interface to the human lander. And our instrument group, which is co-led by me, is doing the interface to the instruments. And we're trying to make this as portable as possible, but also as compatible as possible with a large variety of instruments and sensors. And I'm going to link it back to ISRU at the end here if there's some other uses to it. And we're in the middle of this right now. This is some of the details. LESSH Placed PL is what we're doing for headquarters. There is an internally funded version that is LESSH handheld. You can see a little version of it down there. There's two versions of design, one meant for the future when we can maybe Artemis 4 and 5, we have more size, but this is designed right now for the Artemis 3 size. And what will, at least in the near term, be the package you will have to design an instrument to, you will have to design a drill to, you will have to design a sensor to, or anything. We're trying to rapidly mature the concept and then build the flight unit is really where we are. This is what it looks like right now. We're about to go through a safety review for the interfaces for electrical and for the handles. What you see on the left is what we call the common service module. And that is essentially where the human rated batteries live, or our Space Cube Mini lives, which is processing for you. This is where our thermal control system lives. This is where our radiator is. Power distribution card, and a comm system. We were one of the examples used in the Artemis planning program a year ago. The local comm to get data back, or ISRU data back, or anything back was not well thought of early on Artemis, and we've been one of the pathfinders, I think I'd argue, to have that stuff included. It is a local Wi-Fi Ethernet system. This is a little bit more about the mechanical and thermal and the interface. We can customize this somewhat, but we're trying to build the first unit to be compatible with anyone's instruments. It's a pretty capable system. One of the challenges is batteries, I will tell you. If you're going to try to do anything on the surface of the moon, the thermal scenarios you may live in, depending on your orientation, are extremely challenging. We've gone through this a lot of times. We've applied a lot of lessons learned here, isolation, but also human rated battery and voltages are not a minor issue when you go through safety reviews. What we tried to do here is solve those problems. These are actually the batteries baseline for the suits modified for this effort. And these are long lead items, so it's a big issue for A3DI, and we've got a head start on some of these power systems. And I can answer questions later. The core service module is what's on the left. What's on the right is where your instrument go. It's where your ISRU sensor would go. It's where your drill would go. That is a customizable box that builds that interfaces. Right now, this is a smaller version of it. Theoretically, that could be a big box linked to a small core service module in the future if there's size for it. But again, this is, think of LESSH as all the stuff we want to do that you heard of here and earlier on the surface. This is the thing that nobody talks about that you need to do anything, which is power, comm, thermal, interface, get on the lander, get down from the lander. This solves all those problems so you don't have to. And again, it was a selfish motivation at first because we have instruments we can't get down. But these designs, especially the summaries of the designs, are available to everyone. I'll talk about that in a second. We're building this to 7120.8, except for the interface to the lander and except for the safety reviews. Those cannot be, and that's very similar for those of you who are after A3DI instruments. That's a very similar situation. We've designed all these interfaces. We do not currently survive the night. There are future versions will. We've designed that system, but there's another box, I'll call it LEMS, that Goddard builds. It does survive the night. I can talk to you about that some other time. We're kind of focused on A3, A4, Artemis 3 and 4 right now, so it's kind of close proximity. We're capable of being repositioned. You can imagine how it might link to ISRU if you wanted to do subsurface sensing, if you wanted to build, bring a mass spec to a hole just drilled, if you wanted to cap a hole. This is really compatible with what I would call old school surveying. You know, we're an astronaut. You might spend a half a day on a sortie going through looking for subsurface. Ground truth was actually relatively difficult, as you know, as you've heard earlier. Something to keep in mind, it's not so simple about building one unit. Anytime you send anything to the surface of the moon other than PRISM and CLIPS, you will need one flight unit, one protoflight, one ETU, 2 training units. That's a difficult thing to provide because there's a lot that goes into astronaut training and backups. For those of you after A3DI, our timing, because of our funding essentially makes us ready for A4. But what we are doing for Artemis 3 is we're sharing our architecture here. We have a 2-sheet summary, so you can use that. We're sharing lessons learned. We've gone through a year's worth of work interfacing with HLS, going through surface application scenarios and lander interface scenarios, and we can share that with you. And we're working to accelerate battery, avionics, comm solutions. Again, you're going to need all those that are compatible with the lunar environment. And right now we're working towards being available as a flyable prototype for Artemis 4 proposals, which who knows when that'll be, but probably within a year. And I'm done. I'll take questions. Maybe I'll put us back on.
All right. Great. Yep, we have time for a question.
Yeah, hi. We're really good that you're working on that. And in fact, I have a question about the A3DI call. Where does one get requirements for what the astronauts, you know, for how to build something that can interface with astronauts? Is that in the call, or is there a source? And how did you like the size of the handles, how big to make them, that kind of stuff? Where does one get that information?
Come talk to me. It's complicated. When we started this, none of that existed. In fact, the beauty of LESSH a little bit, I'm kind of maybe over advertising, is that we were one of the few examples when they were trying to write the call. Like we had asked a lot of these questions about where do you find that stuff. There are references in the call that you can go down, and if you go in the right direction, you will find a lot of the requirements for safety reviews, and in those requirements, you will see the things you have to design to. There are clearances, there are distances, and in fact, even the handles have to stay in the volume that the A3 prescribed. What we're hoping for is that A4, A5 as the volumes grow. In fact, we're one of the groups pushing for that. Not that it's needed now, but in the future, you'd hate to be limited to that mass and that volume. And we think there's certainly capability, and we'll be the example there for you. But I can help you find that stuff if you want it. But it takes a little bit of detective work to find all the requirements.
Carl,
Right.
just to Mananam, NASA headquarters, part of the group in charge of the Artemis 3 deployed instruments call. You were asking about where you can find the requirements for it. So we've got the safety document is still in review. But what we have in the proposal information package that is online along with the solicitation on Inspires gives you what we're going to hold the proposers to. If you are looking for something in particular and can't find it, please contact us. Our email is in the solicitation, and we'll respond to you. And that, of course, goes for everyone in the room and listening online.
Okay,
Yeah, one
Um,
thing I'll say, you
thank you.
can find it. If you follow the link, they did a good job, especially how last minute some of this happened. You can find all your links if you follow the library information in the call. You will find it if you look through it.